Okay, welcome back to Physical Geography Lab, and let's take a look this week at climate classification. Pretty interesting system to be able to understand the patterns of climate distribution around the world, and a key tool in physical geography. And obviously climate's something that pervades so much of our daily life and so many of the sciences in general. So we need to get some little bit deeper understanding of how it's classified and distributed, and refresh some of those principles that we learned in a physical geography lecture. So just a heads up that next week will be the midterm, and it's approximately 6 to 8 questions on each of the previous lab topics. It's open note and an open lab manual if you had one of those. That's just to say that in terms of the online class, the lab manual is just what's been transferred into each one of the lab worksheets that you work through. That includes the questions that then you put into the submission sheet. So even if you don't have one of the lab manual printouts, that's what we've provided in the modules here. But really importantly here, each of your exams must be completed independently. Okay, so asking for some real honesty there and independence, and yeah, I really appreciate you all stepping into integrity with avoiding working with other people. So thanks in advance, and I'm sure you understand why, and it's always serves us well to exert our own independence and not try to cut corners. So, climate. Weather conditions prevalent in an area over a long period of time, right? Weather over time. Weather happens today or tomorrow or this week, while climate occurs over many, many years. So that's an important thing to keep in mind and understand about climate. And we have the Köppen climate classification system. I guess most commonly in North America, we're just going to hear it pronounced as Köppen. I don't know, I don't speak German, so I don't know the actual native pronunciation, but the textbook has this note about it being pronounced as if K-E-R without the R, so I don't know what they're going for there. I'm sure we could pull up a YouTube or something and get a better idea. Vladimir Köppen devised the most widely used system. Pretty neat. He was a botanist as well. And obviously climate playing a big role in the distribution of plants. We have a whole subfield of geography called biogeography, and the botany on the landscape plays a big role and offers a lot of insights. Obviously has affected humanity greatly as well through evolution. So it's what's known as an empirical classification system. That is, it's based on observations and resulting long-term averages. So empirical is an adjective that expresses, it's based on observations, as this little bullet point says, experiments and like factual observations is the best word coming to mind. In 1928, he unveiled the first wall map showing world climates. It was co-authored by a student, Rudolf Geiger. And here's a look at that map. And we can begin to see some of these different zones, climate zones. What strikes my eye the most at first is the yellow areas, arid zones, many different deserts, Even southern Patagonia is a desert, but obviously the Sahara stands out, and the Great Australian Desert into the Gobi, Central Asia, and even the Mojave here, Sonora Mojave, extending into the Great Basin and Range, or the Great Basin Desert. It is as well. But yeah, we can also see some other patterns emerging as well. More humid, wetter areas. But let's take a look at the classification system a little bit more closely, besides just trying to get an overview of the map. So there's three things that the Köppen climate classification system is based on. It's average monthly temperature, average monthly precipitation, and total annual precipitation. So that's our base. That's what we want to really understand as the fundamentals to this. So how is average monthly temperature calculated? How is average monthly precipitation calculated? How is total annual precipitation calculated? Okay, that's you know, as critical thinkers and students with our geography hats on, myself included, right, for life. These are types of questions that we can imagine when we're told that it's based upon three variables. Anything, right? What, why, when, how, where. So, the primary classes, what this is going to look like is each of these climatic classifications being three letters, either uppercase or lowercase. Primary classes are based upon temperature and indicated by uppercase letters. So A for tropical humid, B for dry, C for mesothermal, or in other words, mild mid-latitude, microthermal being severe mid-latitude. Think of how elevation might be at the same latitude as somewhere else. You know, Everest in southern Florida, for instance, Mount Everest, being the same latitude, but drastically different temperature profiles. So meso and microthermal. And E for polar, including the highland class. So, you know, perhaps somewhere as high as Everest, my previous example there, would be closer to a polar climate. We'll find out. So here's a distribution of the tropical humid zone. And the scale across the bottom is just the range of the different classifications. Here's arid, speaking of that basin and range, the Great Basin Desert of Nevada through, well, really the eastern Sierra, over through Colorado and southward. Yeah, interesting Central Asian distribution again, the Kalahari in southern Africa, and here you can see our southern Patagonia desert as well. Interesting that the Antarctica and Arctic aren't on there. There's a separate classification for them, but they are actually very arid. The world's two largest deserts, Antarctica and the Arctic. So here's mesothermal. You can see California, for instance, all the way up through the panhandle of Alaska, yeah, various parts of Mexico, and yeah, it looks like all of Europe, except Iceland. Not all of Europe. You can see different zone for Scandinavia there. Let's go to the next for microthermal and see the rest of the distribution there. And here's polar, so it's getting its own classification for the temperature. Right, so we're looking at our primary classes here based upon temperature. Just to jump back for the pre-map slide there. Just take one more look at polar, the very southern extent of South America, of Patagonia, the Tierra del Fuego, being a land, a continental distribution of outside of the Arctic, outside of the polar regions, that is. Pretty interesting. similar to northern Alaska, and Canada, Siberia. The only part of the southern hemisphere outside of the Antarctica that shows up in the polar region. I don't know, I always try to look for outliers on maps, and especially thematic maps showing a distribution, right? Because that's where we can really start to understand patterns. It's kind of the unique elements that stand out the most, give us really neat access points for understanding patterns and some of the more nuances that they describe of landscapes, whether it be human or physical or all points in between. So a little prompt for us here. What is the primary class for Diablo Valley College? Probably some of you might have seen it stand out there, but if not, you can scroll back a little bit on the video and take a look. So then we get to secondary descriptors or modifiers. These are lowercase letters that describe precipitation, right? It's our second main variable. After temperature coming precipitation. But only for A, C, and D climates. Okay. For secondary descriptors for B climates are uppercase letters and indicate a degree of aridity. Kind of a neat word for us. So S for steppe, precipitation more than half the potential evapotranspiration. Okay, so you're getting tying in some of the botanical or biogeography element there, evapotranspiration. A little throwback to a physical geography lecture as well. And then W for desert, or precipitation less than half of the potential evapotranspiration. So the difference here being more than half or less than half. And, you're just thinking about it. Usually steppes, although they can be quite arid, generally due to a little bit of elevation uplift or various microclimate factors, or perhaps as our variable points to here, a little bit more evapotranspiration. Steppes in general, we can think of as having more vegetation compared to full-on deserts. So that's a little thought process around. Well, we have for B climates, we have two different ones: steppe, desert. Not that you have to memorize any of this, but just to try to help think through when we're seeing precipitation more than half, precipitation less than half. So I think you get where I'm going there. Just to try to avoid specific memorizations and just thinking through. Well, what do we know? What do I know about a steppe versus a desert? And what types of patterns across space can I visualize with it? And then our tertiary descriptors are our third ones, right? Tertiary just being a big word for third. Indicate additional seasonal temperature differences between classes. So for instance, A for hot summer, the warmest monthly mean being average, it's greater than 72 degrees Fahrenheit or about 20 degrees Celsius. I'm just going to stick for Fahrenheit for this whole lab, but yeah, it's good to keep those in mind. B for cool summer, the warmest monthly mean is less than 72 degrees Fahrenheit. It's an interesting west coast of North America correspondence there between those two. And C for 1 to 3 monthly means are greater than 72 degrees Fahrenheit, exclusive to the C and D climates. And there's really neat flowcharts in the lab that will walk us through very clearly how to delineate these or how to distinguish. So it's a lot more helpful than I find anyway than seeing it written out in a quite verbal format, bulleted form like this. And then D, the coldest monthly mean is less than -36 Fahrenheit. Quite cold. That's very cold. And what's kind of neat here is we're almost approaching -40. We are approaching it, but yeah, almost at -40 Fahrenheit, which is where Fahrenheit aligns with Celsius. So -40 Fahrenheit, -40 Celsius are the same temperature. Okay, so what would be the tertiary descriptor for DVC, do you all think? You can, do a little research and yeah, add it to the discussion board, see what you think. Maybe after you do your research, we'll go through some of the, you could go through the flow chart with what you come up with and then find out what you think it is. Okay, so tertiary descriptors, what's also for B climates, also keep in mind here, they indicate temperature differences but are not used with other climate classes. So we have H for heiß, if that's how it's pronounced in German, for low altitude hot. The mean annual temperature is greater than 64 degrees Fahrenheit. And then K for kalt, or mid-latitude cold in German. The mean annual temperature is less than 64 degrees Fahrenheit. Okay, so just further specificity for B climates there. This will all become more clear once we dive into the flow charts, as I said, and you see some of the climate graphs in front of you. So just to encapsulate here, primary, secondary, and tertiary descriptors. Each of the letters that indicate the specific Köppen climate classes are case sensitive. Okay, for instance, uppercase C, lowercase sa. These are important. Okay, very important. Do not do not randomly mix and match secondary or tertiary descriptors with primary class descriptors. Okay, we want to be precise here because it's means something different if you do it otherwise, right? And we gotta play by the rules. Okay, so a climate graph. You heard me say that in the preceding slide, and perhaps thought, what's a climate graph? But it's a graphical representation of climate for a given location. Okay, I think these are one of the really neat parts about studying climate, is getting to see how it graphs out. Much more of a visual learner. I think a lot of geographers are, a lot of scientists in general, whether it be social or physical or psychological sciences. I don't know how visual learners they are, but I'm sure there's plenty. Okay, so it can also be spelled with a climograph instead of the O in the middle and A, or you might hear climate graph, but we're going to go with the more common climograph. And the lines indicate average monthly precipitation, okay, and average monthly temperature, blocks versus curved line. And this is what we're working with here. I don't have the exact location for this specific climograph. Oh yeah, we're working up to that, but this is just to give you an example of the curved line versus the blocks, and a drop in temperature in the mid part of the year, June, July, August, what we would consider in the northern hemisphere to be summer. However, this alerts us to the fact that this is a southern hemisphere location, most likely, with June, July, August being lower temperatures. Okay, and so our precipitation is across the bottom here, the bottom bars, in this case in millimeters, averaging around, well, in the summers, around 50 millimeters per month precipitation, and dropping into August, September, a little bit lower precipitation there. But this is for, as we said, the southern hemisphere. This is for Walgett, Australia, in New South Wales, eastern central Australia, and the northern part of New South Wales, and the interior slope, interior side. Right? There's coastal mountain ranges here in Australia as well. And this is an example of some of the natural landscapes from there, grasslands, scattered trees. Okay, so in the northern hemisphere, most likely, right? There can always be outliers or differences, but the temperature line graph is going to resemble more of a bell curve due to June, July, and August having higher temperatures. And we see a corresponding dip in precipitation. Okay, and here we've switched back to the imperial system with inches for precipitation and temperature Fahrenheit. And so, and keep also in mind these are mean monthly temperatures. So if you're trying to think like, oh, well, this is somewhere where it only reaches, 75. Well, you got to think that's an average of daily and nighttime temperatures throughout the month. So really daytime highs could be much higher than that in somewhere where this climate graph comes from. And so this week's lab procedure, please start off by reading through the lab worksheet completely through. It will give you, a lot more clarity if you haven't already read it, to read through the full thing first before just trying to pick off one section at a time. Okay, then we want to carefully plot the climate data for each station, right? Each place. You'll see there's various associated files with this module, and go ahead and download those. A lot of them are embedded. In fact, each of them are embedded within the worksheet as well. You can pull it right in there, but you're going to want to insert data into it, either if you prefer to print it out and handwrite in it, then scan it, or take a photo, turn it into a PDF to send it to submit, or doing it digitally. I know some of you are quite skillful with all the different digital tools that exist these days. So, and this will make more sense as we dive in here, plotting for each station mean monthly temperature, connect the dots to form a curved line, and the mean monthly precipitation representing block form. Okay, so for instance, Montreal, Canada, Montreal in English is one of the stations, one of the places we're going to do this for, and here we're seeing an example of this completed climate graph with the information filled out. See, temperature and precipitation. Mean monthly temp, the warmest month is 70 degrees Fahrenheit. Pretty nice. In, let's see, July or August? Yeah, we're about late July there. And wettest month being January, not a big surprise. Oh, excuse me. So that's what you're going to fill in, and then just a reminder: you don't need to fill out vegetation or economic activities or soil information. So we've excluded those there. So first, you want to enter the station name for each climate graph, and there's a whole file that gives all the relevant information for this for each one of these places. And then we want to fill in the temperature information on the right side of the graph. Warmest month and mean, coolest month and mean. You get to generate these means, so it's that's just a part of doing geography, is compiling means. So you get to be geographers this week and the other weeks too. Okay, and so mean annual temperature found in the data table under YR. Okay, and the range, the difference between the warmest and coolest months. And make sure to use appropriate degrees Fahrenheit versus Fahrenheit degrees. Let's continue here. Include the following information regarding precipitation: the wettest month and amount, the driest month and amount, and the annual total. Okay, then again, the mean annual precipitation is included in the data tables under YR. So let's take a look at that. So for instance, all the way over on the right there. Okay. And the yearly range. Okay, and then excuse me, the mean average annual temperature. And that's over to the right. And in terms of mean total average annual precipitation, that'd be the second row. Okay. YR just for year there. And then I'm going to assign the primary climate classification for each climate graph. Okay, so start here at the top of diagram 1. You'll see that in both embedded in the lab and then as a separate file you can use. We plot the average annual temperature and precipitation for the station on the boundary chart, which is graph 1 as it's labeled in the lab worksheet, and determine if the climate is BW, BS, or humid. Okay, so we have our mean annual precipitation across the bottom here and mean annual temperature across the y-axis. And where those combine, you're either going to be in the BW for arid, BS for semi-arid, or A, C, or D for humid. If the climate is BW or BS, assign a tertiary descriptor. And we do that based on if the temperature is of the coldest month is greater than 32 degrees Fahrenheit, then the tertiary class is H, right, for heiß. If the average temperature of the coldest month is less than 32, then K for cold. To calculate the average winter precipitation, take the sum of the winter precipitation months and divide by average annual precipitation. So the northern hemisphere winter months are October through March, southern are April through September. Okay, and then average winter precipitation. Is the winter precipitation at least 70% of the total annual precipitation? Yes or no? That's what the question is going to prompt us. Let's look at the data for Naples, Italy, for instance. Total annual precip is 34.3 inches. Winter months for Northern Hemisphere, October through March. These are in the climate tables. You'll see for Naples, we have October through March corresponding to these values. Adds up to 25 inches. 25 divided by 34.3 is 72.88. And so yeah, it's winter precipitation is at least 70% of the annual. Right, so follow that on the flowchart, and that then the next step of the procedure is once the secondary class has been determined, assign the tertiary class using diagram 3, and I included a little snapshot of that here for you. It's a series of if, comma, then questions. If the temperature of the warmest month is greater than 71.6 degrees Fahrenheit, for instance, if it's yes, then the third letter modifier is an A. If no, then you go on to the next questions. It seems like a lot of words to speak through and maybe tough to visualize it, but I think you'll find that the way we've laid it out in the worksheet, as well as the clarity of all the data being presented in one file, you don't have to hunt around for it. I think you'll find it's a lot easier than at first it seems a lot to students, but it flows really well once you jump into it. Once the primary, secondary, and tertiary classes have been identified, find the appropriate name of the climate. Okay, and this is found within table 2. So you don't want to just leave it as CSW. You want to include the official climate name, climate type that comes after that. And those are all, right there within the table for you. Okay, and then we want to, lastly, of course, enter the recorded information, column next to each climate graph, into Lab 8, Canvas assignment, and go ahead and submit it. So, yeah, let me know if you have any questions. And thanks for listening, and have fun with this. It's kind of a different style of lab, and I think you'll enjoy it. So yeah, take care, and look forward to our discussions. Thanks.